This session, we are going to see about the cross-validation in Python. First of all, we are supposed to upload the dataset. For uploading the dataset, we need to import the library. So, as a first command, import pandas as pd, and we are reading the dataset using the data underscore CSV. So, having the data frame variable assigned to a data frame variable, we are reading the dataset. So df is equal to pd dot read underscore csv. The data set has been read, and we are having the first 5 rows of the data set. And moving on to it, we find the data set starting with id, diagnosis, radius mean, section mean, perimeter mean. These are the additional features. So 5 rows and 33 features are there in this particular data set. As we move on, we are going to split it as dependent variables and independent variables. So x is going to be the independent variable. We are just locating all those independent variables as x, and similarly the dependent variable, the diagnosis, is going to be the outcome, the target variable. So y is going to be the target variable, that is the predicted variable. So we are splitting it into dependent and independent variables. So on moving this, we found the code to be executed, and x hat is going to be the radius mean, section mean, all those, and finally we got NaN. So NaN is not a number, so you can able to drop that using drop Na, not a number. So after this execution, you can able to remove that particular column. So NaN column has been removed from the independent variable. After this, we are just going to have y dot value underscore counts. So which returns. So we have the one type of classifier, Benin classifier, is going to be 357, and the Mulligan classifier, Mulligan type of cancer is going to be 212. So for this, we are supposed to carry out the various cross validation techniques. The first one is your hold out cross validation, which is going to be a simpler one. When you are going to have a model to be tested with 80 and 20 percentage, the normal traditional way of executing your model will be your hold out cross validation. So for this, we are implementing your decision tree classifier. So from sklearn.tree, import decision tree classifier, and from sk.model underscore selection, we are importing train test split. So where the train test split the method uses the dataset with independent and dependent variable. Capital X is going to be the dependent and Y is going to be the dependent variable, the target variable, and the test size is going to be the 30.30, which is going to be the 30% of test size and 70% of training set. And the random state by default we can able to use 0, or as of iterations we can able to change the value of it. So for each and every values of the random state, the result varies. So this, it returns the 4 values to it, the x train, x test, y train, and y test. So we are obtaining a train and test split over to the data set. After splitting it, we can able to apply the model. The decision tree classifier model has been defined and it has been fitted out for the particular train data set. And once the model has been fitted to the train data set, we are just going to find the score of the model with the test set. So on finding the test set, we can able to have the values to the net result. So on printing the values, on adopting the value of model of decision tree classifier, we can able to find the accuracy of 0.95 as a test score. So this is the basic of train and test set implementation using hold out cross validation. The second type of cross validation is going to be the k-fold cross validation, where you can able to have k-fold, that is how many times you can able to have its iterations done over to the entire data set. So for this we are adapting the k-fold model from sklearn.model underscore selection, importing k-fold, and the model, the same decision tree classifier model has been adapted for it, and the k-fold we are assigning 10 folds to be done for its iteration. So for the model to be encubed, we are having the crosswalk score. So for each of the every iteration, we will be calculating the score and finding it the average of the calculated score, then produce the net result. So the crosswalk score have the method has model to be passed to it with the data set, the dependent and independent variables, and CV is going to be the cross validations. Here the cross validation is going to be the k-fold validation. This we are adapting for the 10 folds. So this we are calling upon for the crosswalk score, and this can able to return the results. So for 10 fold we will be achieving 10 results to it, and printing this we can able to see 10 different results will be seen. Upon receiving the 10 results, we can able to have the mean value, or that is the average value for the results can be able to say. When we are having the justification for this k-fold model is, we can able to find the least score is going to be the 0.89, and the maximum score that this model can able to produce is 0.98. So depending upon the various iterations, you can able to have different set of accuracy that can able to be produced for this. So as an average, you can able to generate 0.936. So next type of cross validation is going to be the stratified fold cross validation. For this, we are just going to import stratified k-fold from the model selection xklearn. So this model will be adapted with n splits of 5. So the same decision tree classifier model has been built. For this, we are having a model with x, that is an independent variable and dependent variable, with the cross validation is going to be the stratified fold cross validation. So this is equivalent to the same uh, k-fold validation. Here we are going to have stratified, meaning that we are going to fix the k-fold stripes so that we can able to have an accuracy for it. So when this stratified k-fold will be suitable for any of the model is when you have an imbalance data set. For an imbalanced data set, we are just going to have this stratified k-fold model. So for example, if we have 700 correctly classified and 300 is the other class, 700 falls in one category and 300 falls in the other category. For 700 is to 300, that is 70 is to 30. In the ratio of 70 is to 30 only, we will be making use of the class for a particular iteration. So this also yields the same set of results similar to the k-fold. So it generates, we have been split it into n splits, so 5 different scores has been erased. So the same way 0.89 will be the least score and it generates 0.94 to an average of 91. This model adapts the accuracy. So when this stratified k-fold is suitable is when you have an imbalanced state of classification, we can able to adopt the stratified k-fold cross validation. And the next one is a leave one out model. Leave one out is a simplest one, having 10 set of records. In the 10 set of records, one is going to be the testing part, the other remaining 9 is going to be the training set. Similarly, we are going to apply the cross-val score, applying the model with dependent and independent variables with cross-validation to be leave underscore val. So leave one out produces the net results. So it takes few more times, since depending upon the size of the data, it is just going to take only one as a test set and remaining will be taken up as a training set. So it takes time for its execution. So this is the results which have been achieved from the leave one out cross validation, and taking the mean we could be able to find 0.936 will be the accuracy that can this test can able to be produced. The next one is a repeated random train test splits, which is going to be the hybrid model of normal train test validation plus the k-fold split. So this can able to have shuffle over to this um, selection of data for training and testing. So here we are importing shuffle split for the model selection, and the model is going to be the decision tree classifier. This shuffle split has n splits taken to be 10 and the test size is going to be the 30. So 70 is going to be the training set and 30 is going to be the test set. So this model will be applied over to the cross value score given the decision tree classifier with the data set x and y, applying the cross validation to be the n split 10. We are having the repeated random train test model for producing the net result. So on execution, we can able to have 10 splits, that is 10 accuracy values. For 10 iterations, we can able to achieve the results, and similarly, we can able to have the justification of 0.86 is going to be the least accuracy, and the maximum accuracy is going to be the 0.97. So this model can able to adopt 0.92. So for an imbalanced data set, it is straightforward to make use of the stratified k-fold cross validation. So in this session, we have been seeing the various techniques that are used in cross validation, that is hold out cross validation, that is a normal train and test validation part, and k-fold cross validation. So for every iteration, one will be acting as a test, the other remaining blocks will be acting as a training part. Stratified k-fold cross validation, where when you are having an imbalanced data set, we can able to go in for the stratified k-fold cross validation. Leave one out cross validation, where out of all the out of all the values in the data set, one will be considered as a test, the other will be considered as the training part, and this will takes more time, and this is not the uh, mm, right way of adopting for the cross validation for any of the model. And repeated random train split, you can make use of the hybrid model of k-fold and the normal hold out cross validation. Thank you.